Everyone is here? Yeah, welcome guys. I can see quite a few new faces, so I'm just going to give a short introduction. We are a group of software engineers living in South London. Last year we decided to organize meetups and we set up a meetup group. I think we organized like 7 or 8 meetups last year, and this is our 4th one. And we have an attendee list just next to the drinks. If you can just find your name and tick, that would be nice. If you are not on the meetup, you can leave your email address. We can add you on our meetup group. Today's talk is gonna be about why is simplicity so complicated, and Luke is gonna give the talk. He's a software engineer, full stack developer. Last year he gave a talk about AngularJS and TDD in JavaScript, and that was a very useful topic. And we asked him to give another presentation this year. So I can see that all of you are so excited. I'm just gonna invite him to the stage.
Cheers. We'll make sure that's staying. Alright, thanks for coming everyone. So today I'm going to talk about why simplicity is so complicated, and I'll talk about what do I mean, first of all, by simplicity and complicated, why I think everything that should be simpler is very complicated, and come up maybe with some solutions on how to fix them, or at least pretend that I have solutions. So some background first about myself. I am a software developer from Australia, and I've been mostly working with .NET web development, full stack. Do we have any, who are we in the audience? .NET guys? Java guys? Other? Yes? What kind of support? Support, okay, cool. Are we mostly web as well in the audience? Yeah, cool. So we all do a bit of JavaScript as well then, yeah. I've lived and worked in London for the past 3 years, and since coming here, I think I've really embraced, I've found a lot of people through meetups and the places I've worked that have led me to embrace the ideas of XP, lean software development, and of course, agile, which might be a loaded term to some people. I'm not really going to talk about that too much there. So first of all, what do I mean by simple? So when I'm talking about simplicity, and that I think normally simplicity is a good thing to strive for, I think there's a quote about a perfect design being not when you've added everything you can, but when you've taken away everything you can, and I like that philosophy. I'm talking about simple code, so code that's small and easy to read and easy to work with. I think we can all agree that we deal with, day to day, we deal with a lot of complicated code. And code gets read a lot more than it's written. You write code once, and then sometimes it stays for years or decades and has to be read over and over. So the simpler the code is, the more quickly it can be read and worked with, so it can be maintained. By the same token, I think a simple architecture, so how we actually build our systems and how we have the different parts communicate with each other and work together. It's the same principles as keeping code simple in the sense of the benefit it gives you. You can work with systems more easily, you can reuse them, you can change what they're built for. You can change from what they're built for to serve different purposes. Of course, the problems can be different compared to just actually building simple code. And finally, simple user experience. So I think there's a lot of systems, applications, websites that could be a lot simpler to use for the end user. I don't know, so many times I look at enterprise apps and they're just a big complicated mess normally because they're written by people like me, by developers. I think there could be a lot more less complicated UX. But some people might argue that if we're dealing with complex problems, complexity has to live somewhere. If you've got a problem which is like this, if you've got you're working at NASA, you probably have really complicated problems, and the complexity, maybe the solution is just going to be inherently complex. So what I'm really talking about today is essential complexity, which is the complexity of the problem that you're trying to solve, versus actual complexity. Or I think I meant to write accidental complexity there. So the complexity of when you're trying to solve the problem, you solving it in something which isn't the simplest way. I'm just going to start a timer to make sure I don't go over time. Let's do that. Okay. So first of all, I'll dive into complex code. So, has anyone seen the enterprise Fizzbuzz? Who knows what Fizzbuzz is? Someone? What's Fizzbuzz, Hakai?
What's the game, is it?
It's like a kid's game. And
it's a kata experience.
It's like a kata. So,
yeah.
There it is, if anyone can read that. So, go through the numbers 1 to 100, print out the numbers, but if the number is divisible by 3, print Fizz. If it's divisible by 5, print Buzz. If it's divisible by both, print Fizzbuzz. So it would print out 1, 2, Fizz, 4, Buzz, etc. This is a common coding kata to practice. Maybe if you're learning a new language or a new technique or a framework, you can go through Fizzbuzz because it's ultra simple, right? Or so you would think. It's also a lot of companies use it as a kind of take-home interview kind of assignment to see what do you consider maintainable code. And someone's written a Fizzbuzz which is enterprise quality. So it's not just an implementation of Fizzbuzz, it's an implementation of Fizzbuzz that can be extended in any possible direction. Maybe I don't want to have Fizz or Buzz, maybe I don't want it to be divisible by 3 or 5, maybe I don't want it to go from 1 to 100. I actually, so it's on GitHub, I cloned it and have it in IntelliJ, so I don't know how easy it is to see on the left, but I just opened up all the different, so that's just namespaces there, and then all the factories, there's all the different factories we have. That's how you go through the loops, I suppose, if you want to be able to loop in different ways. There's math, there's printers, we have a Buzz printer. How do I do that? So we have a system out Fizzbuzz output strategy factory that a Buzz string returner. This prints Buzz, I suppose. So they've got hundreds and hundreds of lines. Yeah. So this is good high quality code, right? This is clean because it can be extended and manipulated in lots of different ways. It's future proof, right? So even though this is done kind of tongue-in-cheek, as someone is making a joke here, obviously I hope so. It's somewhat based in reality. I don't know if many people here work in large companies or have in the past, but some of the ideas in this seem really real to me, especially things like trying to make everything fit into a pattern, just to see how many different factories you have. And the idea that making things extensible means the code is good quality. So having extensibility points over printing Fizz or Buzz, for example. But it's a trade-off, right? I think, go back to, so it's a trade-off between making things extensible so that you can change them for the future and so that everything's broken apart, and readability, because instead of doing all of that, you could just do this. I think that's a little bit easier to read, maybe. And
little bit.
And what I find ironic is that someone who would make a solution extensible, like the enterprise one, is saying that now this solution can easily be modified in the future. I think it would take a long time for me to go to that solution and make it say, if it was divisible by 4, print FOS. I think it would take me a long time to do that in that code base, whereas in this code here, I think I can do that pretty quickly. So, I don't know if everyone agrees with me, but I see code like the enterprise Fizzbuzz a lot. I think I see it more often. I think I see over-engineered code more often than under-engineered code. Does anyone agree with that? So put your hands up if you think the balance is more in favor of over-engineered code in the industry. Yeah, yes. And then some people maybe think that we have the balance in the wrong way towards under-engineered code. No hands. Okay. So
depending on the context and the project types.
Yeah, but overall, do you see? I just, maybe it's the places that I work, or maybe it's because I'm a .NET developer and people who work in the Microsoft world just make things worse. I'm not sure, but I just feel that I see it. Maybe it's the companies I work for in London, but I see it all the time. I rarely see under-engineered solutions, or at least the ratio seems to be strange, in that I see solutions that are so over-engineered that it's as if they're under-engineered. They can't perform and they can't scale. So this talk came from me having lots of conversations normally at the pub with people, other developers, and other people saying the same thing back to me, and me just thinking, I've been thinking maybe for a year on this, why do we do it? And I'm going to pretend that I have some answers tonight, and because I'm standing up here, I get to say whatever I want.
I think one of the reasons people do it is to boost their CV.
CV-driven development?
Yeah.
That's definitely a real thing. Here's some of my thoughts on what I think. I think the pressure to deliver features instead of refactoring the code leads to examples like the enterprise Fizzbuzz, where you just write out the code, and then as soon as it does what you want, you move onto the next user story or feature or whatever. So rather than spending time, because writing out code to solve a problem is different from writing readable code. I think it normally happens in 2 steps. You solve the problem, and then you examine how you solve the problem, and you think about maybe renaming variables so they make more sense and rearranging the code. And that second step happens after the problem's technically solved and you've delivered the business value. So especially if you're under pressure, and a lot of developers feel pressure and are under real pressure to get features out the door, you either say that I don't have the time for it now because of the pressure, or you say that it's going to happen later. And I don't know about you guys, but I've never been in a situation where I've said we're going to refactor later and it actually ended up happening. Scheduling for refactoring time for the future is you're just giving up pretty much. So I think that's a big factor. Also, it can be more fun to work on something new. So maybe it's not that you're feeling the pressure, it's that you just want to write code. And refactoring code and making it look nice sometimes can be quite difficult because it's really subjective about is this name of a variable or function better or worse. You have to think about it, whereas it's just fun to write code that does stuff, right? And also it's impressive to people when you show your project manager, look how much code I've written today, look how much we've delivered this month. They think, that's great, you're an awesome developer. I'm going to move you on to a new project because you've delivered so much, and now you move away from the code base and someone else has to go through and support it and fix it up. There's also maybe the fear of negative feedback. So I'm thinking this is maybe a more psychological one. If you show your code to other developers, say if you have code reviews or if you pair program a lot, you're going to get a lot of feedback, which is, I think is a solution to solving the complexity problem of your code, is to show other developers and say, what do you think of this? Especially if they haven't seen it, can you read this? And when they're reading through it and they struggle with it, that's where you can kind of improve it. And that helps a lot to me, to show another developer my code, to find the parts that I struggle to explain to him are the parts we'd have to refactor. But by the same token, me getting that feedback, it could be seen as negative feedback. You know, the code that you've written is bad quality. You show another developer and he says, well, this code is shit, I don't understand it. So maybe there's some developers that have that fear. They might not even realize it. They don't want to show their code to other people. They just, look, the code works, I want to move on to the next thing because I don't want you to tell me where I've gone wrong. Which is another irony, right? Because if you don't get feedback, you're never going to improve. So you're always going to probably have that fear of not wanting to get feedback. And it's just a perpetual cycle. And another
Is the fear of negative feedback, is it reason to complicated code?
I think
it's other way around.
I'd say one of the root causes of writing complicated code is not spending time on refactoring it and making it simpler.
But if you want to, if you are going to show your code to other developer, and probably you don't want to hear negative feedback, so you are going to put your best effort to make it most readable.
Or you just don't show them, right? If I don't want negative feedback, I can. So the same person that might be afraid of showing their code because they get negative feedback, maybe it's easier to just not show their code as opposed to making it better. But then you might also get into I found this myself. I'm a fan of pair programming. I'll mention that. And I think that I used to, before I liked pairing a lot, I think I used to sometimes get stuck in a cycle where I'd want to show someone my code, but it's not quite polished enough yet, so I'll work on it some more. And I get really stuck into what I'm doing, and it just never seems right, and I kind of go around in circles for ages, whereas if I stopped and I just showed them the unpolished code to begin with, we could polish it together, or I could get feedback from them. And so I try to think about a few years ago, maybe before I wasn't so open to feedback. I try to think about how I felt, because I think a lot of these things, it comes down to psychology, especially this last point. It comes down to psychology, and I think a lot of software developers might have a similar mindset, or there's enough software developers that have maybe more introverted technical mindset where they're going to feel these things. So this one might be a more controversial thing to say, and you probably need more evidence to really say it, but I'm just going to say it anyway. I think there might be a problem with introverted developers being uncomfortable with working really closely together, because a lot of what I talked about in the last point was getting feedback, and that requires showing your code, talking about it, being able to verbalize your thought process of what you're working on. And maybe if you like computers and you like talking to computers, you're not so good at talking to people, or at least you don't like it. And so if you're uncomfortable with just talking to people and working closely with people, maybe you're more likely to just kind of want to work on your own thing. And by the same token, you might be afraid of shared code ownership, because you want to work on your part of the system. It's your baby. This is my code here, and I write it. And that also feeds back into the fear of negative feedback, because it's your code. Whereas if you pair, or if you move from feature to feature throughout the code base, and if you show other people your code and you work on it together, the code is no longer yours. It's always written by more than one person, and so it's a shared code base. And then it becomes, if you have a healthy team that have a collective code ownership, well, now it's our code. And when there's bad code, it's because of us, it's not because of a person. And I think that can turn into a really positive cycle, but if you're already in the negative cycle, it's really hard to pull out of. I mean, part of all this could be because as a developer, there's just so much we have to learn. We learn so many different things, and it's hard to know what's important and what leads to good quality code. I mean, everyone wants to write good quality code. I don't think anyone would disagree with me. No one says I want to write bad quality code. We might have different opinions on what's good and bad quality. We might have different opinions on how to get there. But I think developers spend a lot of time reading code. We spend a lot of time reading bad code. We're always trying to come up with ways to write better code that other developers can read. But when you get, first of all, you have to learn your language syntax. So whatever your main language is, you have to spend time learning that and honing that. Maybe you swap between languages. I know pretty much everyone that works in the web now has to learn JavaScript. We're probably going to have to learn SQL or a SQL-like data query language as well. Then you've got to learn object-oriented design. You've got to learn the solid principles, polymorphism, inheritance, composition. You have to learn all your design patterns. I've put a few of my favorites up here. Factories, abstract factories, factories. I think I missed abstract factories. You have to learn the web if you work on the web, so you have to learn all the different protocols. You have to learn how to do front end. Now you have to learn how to do responsive design. You have to learn how to scale. You have databases. It's not just SQL anymore, it's NoSQL. You have to learn the cloud. I've just put the cloud. I don't know how many different technologies are related to that. Everyone's expected to know that now. Then you have to go to testing. We have unit testing, integration testing, end-to-end testing, test-driven development, the continuous integration part of testing. We have continuous deployment, continuous delivery. We now have feature toggles so that you can release code into the wild, but you don't have to turn it on immediately. You can wait and you can do your A/B testing on that. Now we have functional programming is definitely back in vogue, so everyone's learning functional programming. Everyone's doing Scala or F# or whatever, or we do functional in C#. I hear you guys in Java, you've got Lambdas now, so you're probably doing lots of functional programming too, or trying to anyway. And we have domain-driven design, and I haven't even mentioned any JavaScript frameworks because I'd be up here for another 10 minutes. And this just ends up happening to you, I think. I feel that there's such an overload of things, and a lot of the things I just mentioned, if you're working with relatively new technology and you read blogs, you get bombarded with all that stuff all the time. And it's hard to know what's important and what's not. It's a lot to take in, really. It's more than a full-time job unless you happen to work at a place where you can spend the whole time learning. It's really more than a full-time job. And then you're stuck with deciphering all that and thinking of how do I actually write simple code from that. And I actually think a lot of the things that I just mentioned up on that slide don't lead to writing simple code. They lead to writing really complicated code. It's like the design patterns, for example. If you learn design patterns, especially they get taught at school, I got taught at uni design patterns, and I thought that was the goal, is to write code that fits into design patterns, because then other developers will understand it. And it turns out that a lot of people have found that if you write all your code in design patterns, it ends up like the enterprise Fizzbuzz system where nobody understands it, and that it kind of works the other way around. You should write code, and as the code develops, find what patterns there are, I suppose. So to me, all that stuff, while some of it's important and nice to know, to me writing simple code comes down to two things. After you have the fundamentals of the language and your tools and your IDE figured out, it comes down to Yagni. Who knows what Yagni is?
You're not going to need it.
You're not going to need it, right. This is a really hard one, I think.
Under what?
you ain't gonna need it. It means you can just say Yagni for something when a developer suggests an idea like, okay, we've got something that's watching the file system and copying files over. And we've discovered, so most of the files are a couple hundred kilobytes. We've tested it and we found out the limit is 1 gigabyte. So we're going to have to write something that's, in case someone puts a 1 gigabyte file in there so it doesn't crash the system, we have to write some code in there, and then maybe you're just going to stop them and say, Yagni, we might not ever need that feature. Even though it would be helpful in the event that someone puts a 1 gigabyte file in, the amount of time we spend on designing and implementing and testing it is probably not that valuable. And you can start applying that everywhere in your code base. And I think this is really hard as developers for us to do, because we see our job says to write code and implement features. But really, if our job is to maximize business value, then it's to minimize the amount of code we write to deliver the same value. So this is something that's, I try to think about all the time when writing code, but you can also think about it in a bigger scale about why am I doing this? Why am I writing this feature, or why am I implementing the button like this? And I think TDD helps because, or BDD, defining your requirements in terms of a scenario or a test up front means that when you pass that test, I'm done. So you make sure you capture things, exactly how the system's going to work up front. And when you've passed all those tests, you stop your development. And if you're disciplined about that, it makes you come up with, first of all, better tests, and it makes you stop gold plating the system. So the example I said about the 1 gigabyte limit on some file watcher copier thing, if that was in the original specification that the business analyst or the product owner wrote or the client wrote, then maybe we'd implement it. But to me, my example was a developer kind of inserting that feature halfway through development, which I'd say to him, Yagni. And the second one is the 4 rules of simple design. So I think a lot of the stuff that comes out of solid and design patterns they're really nice ideas, but especially for a junior, I think they really corrupt you. They really make you think in strange abstractions. And has anyone heard of the 4 rules of simple design? I know you have. Yeah. It's Kent Beck, right? XP. It came out of Kent Beck, and it's 15 years old. And first of all, his first rule is that the tests pass. So that's another way of saying that the system does what it's supposed to. So this is going back to what I said before about writing your code and then cleaning it up. So the first thing you do is get your code actually doing what it's supposed to, copying that file or rendering that page or launching, sending an email or whatever, whether or not the tests are automated. Then naming, so the naming reveals your intention. So look at how you've named everything in your code. Look at how you've named all your variables and all your functions. Do they actually give the intention of what they're doing? Are you naming things X, Y, or are you naming them cost or days, or are you giving them really explicit names like?
Or loading more functionality under a name that actually is not implied by the name. More function than the coverage of the name implications.
Yeah. So having names that are too generic is a problem, and then you're saying having names that are too, well, that's the same thing, isn't it? Yeah, too generic. It's covering too much. It says that it's doing a lot more than it should.
A method, for instance, doing multiple things, but the method name stating only one part of it.
Right. That's too specific, right?
Yeah.
Yeah. So naming, then remove duplication. So this is, if you use IntelliJ or Visual Studio with ReSharper, we're quite privileged in our static type languages that we can do lots of automatic refactoring, so we can extract variables and extract methods and remove parts of the code that are duplicated. And the final part is make things small. So if you guys want to look up the 4 rules of simple design, there's lots of good resources and videos about how this is, even though it's simple to remember and to think about, it's actually can do a lot with your code. It can actually kind of, if you go deep into it, it's a really nice circular system, because you can go through this. Once your test pass, you can go through your names, make sure that they reveal intent, then you can get rid of your duplication. So if you've got 2 methods that are checking the same Boolean, or maybe say they're checking 2 Booleans in the same place, you can turn that Boolean into a method, right, that has a good name. So then you go back to naming reveals intent. So I'm naming something. then I can make things smaller. And as you make things smaller, you're extracting parts of the code out into different classes and functions. And then maybe you want to make sure that those are named correctly. And then you might notice that there's duplication between them as well. So it's simple, but it's deep. And it's deceptively simple because naming is actually really hard. There's the quote that naming is the hardest problem in software development.
It says it's an art on its own, right?
Sorry?
It's an art on its own, right?
It's art, yeah. Naming things is hard. And I think, especially if I'm naming something which is going to be, say, public, it's not going to be internal to a class, I don't like to be naming it by myself. I want to get at least one other person to name it. So either my pairing partner, or if I'm not pairing someone, I'll just grab the other developer. Can you quickly check if this name makes sense? Sorry, I think this is really important as well to do while you're working on the feature. So it's what I was getting at before is with the kind of developers moving on past the feature. It's like a golden time after you've written a feature, you really completely understand what it's doing and why, and you can rename things. If you leave that feature, if you come back to it even a day later, a week later, a month later, it's going to be new to you. I mean, I don't know how many times I've looked at code and I've just been thinking, what idiot wrote this? And then I look into the history and it was me last week, I wrote this code. It's completely alien to me now. So you're missing a really golden opportunity, which is really an investment in the future of immediately paying down technical debt by going through applying these 4 rules of simple design. So all those, most of those other things that I mentioned in the previous slide, all the patterns and all the different technologies and everything, it's important to know about those things, but to me it comes secondary to this if you want your code to be simple. I think the extreme programming practices really help, so I don't want to evangelize too much about them, but I think, to me, there's no such thing as a silver bullet, but these things are as close as possible. TDD really helps you focus and avoid gold plating. I think pair programming, I mentioned it a few times today, to me it's about getting the feedback so that your code is readable to more than just yourself while you're in the moment. I like the idea of swapping pairs as well fairly regularly, so not only do you learn from each other and you kind of keep fresh, but you get different sets of eyes across the entire code base. And continuous integration, I'm sure everyone here is doing continuous integration, I hope everyone is. That's kind of like a golden bullet that's been so obvious that most people have been doing it for 10 years or more, I think. Just the fact that your code gets built somewhere on a separate server, separate to everyone's machine, so that you never really isolated, you have a central repository of it. We kind of forget, I mean, I've been using it, I've been in the industry 9 years, and I think I've almost always had continuous integration. And I kind of take it for granted that before that, you just kind of pull down changes from other people and just hope it worked. Yeah, like I said, it's all about feedback. So that's what I think it comes down to in the end, including even TDD is about a really short feedback cycle where I've defined what I want my code to do, and now I'm going to find out if the implementation works. And more importantly, as I build up my tests, I find out if it still works in the previous things I do. Do many people here practice TDD every day? A small handful.
Not every day.
The one thing is, I think that everyone in some sense would practice test-driven design because you have to test what you're writing, right? You don't write code and not test it or hand it over to a QA to test it. So even if I wasn't writing an automated test, I would probably still write a couple of lines of code, compile it, check that it works, write a few more, compile it, check that it works. And pretty soon, as I build up my feature, I'll be wanting to check so many things that it'll take me forever to test. And I'll probably start skipping steps and not knowing if I broke it, which is why I think I do TDD pretty much all the time, so that I don't have to go back and regression test. So, the feedback loops allow you to stay focused on what you're trying to achieve, especially TDD, because if you have a test that's red, that's what I'm trying to do now, I'm trying to make it green. At the same time, they prevent gold plating and they prevent you wasting time. I think working with other people helps a lot as well. If you're collaborating close with someone, if you're pairing someone, or if you're asking often for feedback, maybe not just from developers, but from testers and BAs and maybe the client as well. If you're constantly getting feedback from them, making sure that you're doing the right thing, you're going to waste less time. So if you're talking with your fellow developers, you're going to make sure that we're not duplicating the work of each other, that we're naming things well so that we can read it later on. If you're talking with your tester, you're making sure that is everything that I just alluded to okay? Well, it's still fresh in my mind. Have you found any bugs yet? The same as when you're talking to the business and the client, you're finding if you're actually solving their needs. And it's a responsibility on everyone on the team, I think, to be getting that feedback. And I think an understated point about feedback is that, to me especially, it gives me a sense of accomplishment. If I'm getting constant feedback on my work at every level, at the test level from the client, it just makes me feel good about the job that I'm doing. I've worked at companies before where I don't get any feedback from anyone, not the client especially, and I just feel like it doesn't matter if I'm even here today, if I'm typing. It doesn't really matter, so why would I care? And you end up in a horrible cycle actually, where you don't give shit at all about your job, and I really didn't like that. So I think it's important to always remember, as a developer, your job's not to write code, it's to add business value. And sometimes that can even mean deleting code. I think that's my favorite thing actually, is when I've found a big chunk of the code base that I can just delete. And now I never have to read that again, and no one else ever has to read that again, because it still does the same thing. Yeah, I think that might be another pivotal reason why developers love writing code and don't care so much about refactoring, is because that's our job, right? We're to write code. Okay, I'm going fine for time. I think I'll talk about the complexity and architecture now. And do we have any architects here today? One. Oh, I was hoping there'd be more architects. Okay. I apologize for this joke. Why didn't the architect stare out the window in the morning? Because he wouldn't have anything to do in the afternoon. So I apologize, but maybe you can give me some insight here. I'm going to talk about I think an architect is a really strange role. I've never technically been in the role myself. I've never been called an architect. But I think that every developer has to do architecture as part of his job, really. And I've been working in enterprise organizations, or enterprise-like organizations, for the past couple of years, and had some really strange experiences with architects. And this is some of my insights into them. And if you disagree with this, could you please speak up, because I'd like to know if anyone, I'd like to know if people agree with me. So, an architect is supposed to have a big picture view of a system, I think. They're supposed to be a bit step back so they can see how it fits into the overall maybe ecosystem of the company and the business. And that means they're often far from actual code. Do you write code day to day?
My style is a bit different, because I actually do architecture for my own company. So that's why I have to write code and make sure it's quality.
Yeah, this doesn't apply to you. This applies to architects, and I'm not going to name places, but in places that I've worked at recently.
But at the same time, certain organizations, they need architects, and you see, sometimes people looking at them might get an opinion that this guy do nothing, but often it's a very big misunderstanding.
Well, look, can I go through the rest of my points and we'll have a discussion about that? So I'm not going to say they do nothing. I think I'm going to say even worse. I think they're going to. So anyway, so if they're far from the code, or an architect who's far from the code, therefore doesn't have to implement their own architectures. That means they don't have to fix bugs in their own systems, which to me that means they don't get feedback from the architecture, and they don't feel pain. They don't know what works and what doesn't. And I've worked at places where architects are rewarded for building systems or designing systems that are large and complicated because of the fact to a non-technical person it looks like they've achieved more than if they were to build a small, simple system. So if you were to look at a problem, if two people would look at the same problem and one person was to say, no worries, this is a simple problem, it'll take me a team of 5 people, 6 months, and we'll roll it out, and it was successful, then that's great. If someone looked at the same problem and said it's going to take a team of 50 people 3 years, and it's a hell for 3 years, but they release it, the leader of that project might be seen as a much more hard-working, be able to tackle this really complicated problem, which I don't really have an answer for that one actually. That's really hard. That's trying to educate non-technical people in,
in your experience, I've seen actually quite a few architects who knew, because actually you end up working with data designers, you end up with web designers, back-end developers, and a few of the guys I worked with, they knew essentials and every detail of all of those aspects, and actually be able to actually get them suppose a solution which actually works on all ends. It's a very difficult job. Maybe actually that's why you'll see a lot of people who actually just have a title for architect, because actually the one who actually can understand end to end every bit, it's very difficult, and not everyone can manage to do that.
Unfortunately, in my experience, the people that I've met that are architects they weren't doing things like that.
Yeah,
But I don't know. So I've got another point here, and yeah. So for the same token, and so I have a feeling that I was hoping there was going to be more architects to kind of just feel like it's just you and I'm ganging up on you. I was hoping there was going to be more architects to argue against me here, because I have a feeling that this is controversial. That like what you're saying, that some people think that architects are not just necessary but add a lot of value, and I think there are definitely people who can do what you're saying, and that adds value. But in my experience, the people who get all architects
You'll
don't.
end up seeing developers who will hide behind their bullshit, and architects the same. But at the end of the day, it is a very difficult job to do correctly. That's why you will see a lot of people which do exactly the same use case.
But then you maybe have the problem with the developers, who I think it's endemic in the industry. The developers who write this complicated code get promoted up into architects, and then they come up with complicated architectures.
The thing with developers, there are some metrics to actually qualify, like to appraise this work for developer, like tests, passing, and stuff like that. How would you know if the architecture correct or not? Only after 12 months of working on it, isn't it?
Yeah.
And
More. It's a longer feedback.
Yeah, exactly. So that's why don't you the architect will have more time to hire.
Yeah, that's true. I think I've worked at two places now, two big companies, one here and one in Australia, where the architects were the developers who people didn't want to work with anymore. So they promoted them to architects, so they got them out of the way. So you had a team of guys who were just promoted to their level of incompetence, right? And it's not a good thing. Okay, I'm going to tell a microservices story. Has anyone worked with microservices? Has anyone had the pleasure of working on a microservice system? So Hakan knows all about this. Last year, I don't want to name anything because I'm being recorded here to be put on the public internet. I was working at a company and I got moved from a team in the last 2 months of my contract from one team onto another team. This was a greenfield team, although they'd been in development for 18 months. I'd say they were greenfield because they really started completely from scratch that 18 months earlier, and they were also greenfield because they didn't really have any customers yet from 18 months. And this was a system that was a complete rebuild of an existing system. It was a case management system that had been built in VB 15 years ago and then transferred to C# and been maintained. And I worked in that system and it was a horrible, horrible mess. Everyone knows what microservices is, the buzzword of the past couple of years. Does anyone not know what I mean by microservices? No? But maybe I'll just quickly explain it so we're all on the same page anyway. There's an idea that you can build a system out of really small components that are really isolated to each other, called microservices. And so the system is defined by how they communicate to each other, and they each do one thing really well. So normally in code, you'd break up your code into, namespaces or classes. This is breaking it, making the lines of division even more concrete. It's maybe over a message bus or over HTTP, with the idea that way you've isolated parts of the code, so you can more easily identify where to change things. You can scale parts of the system out, only the parts that need to be scaled out. You can release just parts of the system that can be released, and I suppose you can split up the work amongst different teams of developers more easily. So the idea being that a monolith system, which is what most traditional architecture of one giant system, is being really hard. It turns into kind of a ball of mud. It's really hard to develop with. Whereas microservices will be a lot better. And this old system that these guys were replacing was definitely a horrible monolith. It's actually probably the worst system I've ever worked in. But it was absolutely incredible. It did everything. Everything was driven from the database. So all the forms on the screen were completely driven from SQL Server. So SQL Server itself as well had dynamically generated tables that fed into the forms. Then when I dived deeper into the code, I found out, because I was trying to debug some JavaScript, and I couldn't find the JavaScript files, and I was told by the maintainer of the project that the JavaScript was actually generated by C#. So there was C# code behind files, and there were strings of JavaScript and depending on what features you needed on the page, it would grab the different parts of the strings out and then loop through them. And I had logic even on how to put the braces around the different functions and everything. So it was just absolute madness, and I could understand why they wanted to rewrite it from scratch. I definitely empathize with them because I think so many developers, we see a system and we want to rewrite it from scratch if we can't figure it out. But I also think that the guys came in, some consultants came in and contractors came in and said, yeah, you definitely have to get rid of that, rewrite it from scratch. And the next thing they said was, what you need to rewrite it as is a microservice system so that you can get all the benefits of microservices, you can get scalability, and you can get the hot releasing and compartmentalization and all these things. And they really, really solved the business on this. And I joined after 18 months. And I was really shocked to find out that the actual feature set of this system they've been building for 18 months was absolutely tiny. When I asked kind of what the system could do, they were like, well, it can, you can spawn out, it was multi-tenanted, that was one feature, you can spawn out as many tenants as you want, but they didn't have any tenants at that point, I don't think, so that wasn't really needed. You could, each microservice had its own separate database. You could spawn them out on different cloud clusters. It was absolutely incredible. Everything was completely scripted. Everything was test-driven development, and everything was in a separate Git repo. So to get it working on my machine took hours and hours of pulling down from 10 different repos, opening a Visual Studio, building it all through there, trying to corral the script that combined all these things and install these things on my machine, to then load it up, create a tenant, and I got a tour of the entire functionality of this system in about 15 minutes. And then I was done. I was like, oh, that's all it can do. Whereas this system that they're making fun of and they're saying has to be written, this system, well, it was a mess and hard to maintain, it could do anything. It could do anything you want, anything you could imagine. It just couldn't scale, and it couldn't have more than maybe, I don't know, Gordon, how many users could it have at a time? 50, maybe? 20? You can only have 20 concurrent users, but besides that. So I started working on the microservice system, and I realized after not long, after maybe a week or two, I realized that I couldn't actually deliver features on this, that we had some stories come out, and it was so difficult for me to write a feature because I had to branch maybe 4 different repositories at once and then push all of them. We had a really good continuous delivery pipeline as well, where first of all you would make a branch, then you would push that into QA, and then they would install just the microservices from that branch, and they would test it in isolation. And when it's good, then they'd give you the green light, and then you'd merge back into main, into master, and then you'd have to deal with all your merge conflicts of all the different repositories, and then you'd have to push that again, and then find out that even though they tested it in QA on a branch, now that you've merged it back in, it's not working again in QA, so you have to test it all over again. And it was a nightmare. It was 5 or 6 weeks, probably the worst 5 or 6 weeks of my career, because there was 2 other developers on the team that felt similarly to me, that they spent 18 months building a platform but no features, and we thought that maybe we should start pulling back the complicated architecture and the complicated platform. Something for me was, instead of having so many Git repositories, why not have it all in one, so at least we can build at one time and deploy together. But apparently that broke the spirit of microservices. Then we argued some other arguments about making maybe the database a bit simpler, so we have one database, but again that breaks the spirit of microservices. Although we found out that in production we did only have one database server, so it was actually impossible for you to properly spin it out because of some licensing problem. We didn't have a license for more than one database in production, so we never could actually do that. So there was all these kind of arguments that ran around in circles and circles, because the person who was in charge of it, who was technically responsible, really believed that it was the right thing to do, and he felt that the reason why we were finding it so hard to release features and develop on it was 2 things. First of all, the problem was us. The problem was we didn't understand microservices and we didn't understand domain-driven design. And if we did understand it, we'd be better off, which I just found condescending, but really hard to argue. If someone just says, no, I think that you just don't understand it, what can I say back? I can say, no, I do, and you can just say, no, you don't. So that was just a useless discussion. And the other thing he said was, we have to invest more in the platform. If we spend a couple more months investing in the platform, we can get it to a state where we can really bounce off it and deliver features. And I just thought all of that was just absolute rubbish. But he convinced the business and people before him who came on, who, Hakan said it earlier, I think they were practicing CV-driven development. with the whole microservice thing, because they left after a year and went on to do other microservice platforms for other companies. I really think that they just completely convinced the business about all the technical benefits of microservices, but they didn't convince them about the trade-offs, because everything is a trade-off. No matter what you do, it's a trade-off. Even the stuff I talked about before about coming up with really, say, small parts of code. Every time you do that and refactor out to small methods, you're now splitting the code up. I mean, if your entire code base is 100 lines long, and you can read it, well, say 50 lines long, and you can read it on one screen, that's probably not a bad state to be in. You could refactor that into 10 different classes or 20 different classes, but maybe that's okay. So there's a trade-off there. And with microservices, the trade-off is you get all these benefits of being scalable to many users, though we didn't have any users, so we didn't have that problem. You have the benefits of being able to release really quickly, whereas because we were greenfield, we could release, I think microservices slowed us down actually, we could release quickly anyway. It was just, they completely sold the business without telling them any of the trade-offs. This is a little picture I do. I think this is what monolith solutions are. They're big balls of mud, and microservices are now little balls of distributed mud. And that's what we've done. It's a massive buzzword the past couple of years, and I've heard of so many places developing them, and all I can imagine is, well, it makes me happy actually, because I'm a contractor, and so I know I'm going to have a job for the next 10 years, unraveling all these microservice messes that people are coming up with. Just as an example, these are 4 companies that use microservices. I think they have really big scalability issues. Netflix takes up something like 1/3 of the internet for a couple hours every single night in America. That's amazing. I mean, they need something where they can get hundreds of developers to work on a platform and make lots of hot swaps and everything. But we're not Netflix and Uber, and almost never do we have the same problems. I say we, I mean the companies we work for. Maybe does anyone here work for Uber or Netflix or Facebook? No? Okay. So I must say that experience put a really bad taste of microservices in my mouth, and I'm really against them now, which is probably wrong, because everything's a trade-off, right? And you should understand the trade-offs, and there's definitely problems which are classical microservice problems, and there's definitely situations where I think if you've got a monolithic system like the existing system that they were trying to replace, maybe you could be better served by breaking that system apart into microservices so you can maintain the business value. That might have been a better approach.
Microservices, as the name implies, actually, they exist when they are services. If something is not a service, it cannot be a microservice. So in the life cycle of a service development, to some point, until you deliver a genuine service, actually, what you have in hand may not be properly serviced. In that case, actually, the nature of what you have is may significantly differ from what you will have as a service. And then actually, which implies the design structure in terms of the artifact relations, etc., may be different in terms of what stage of development you are in. You may start with a larger system, but it may be better to split it down into smaller services after a while and during development.
Yeah, I actually think a big mistake was, so it was based on domain-driven design, breaking things into bounded contexts. But if you don't have, if you're greenfield and you don't have your major problems solved yet in your system, how do you know what your bounded context is? You can choose users and students and teachers, but they might be tightly coupled and you don't realize it. And I like the idea of, Martin Fowler talks about monolith first. So build your system until you have the problems that microservices solve, and then split it up.
Yes.
But I've been burned so badly by that project now that if I hear the word, I don't know.
I'm sure there will be most spoken practices in terms of the transition into microservices in a more optimal way during the development life cycle of service group.
Yeah. So I want to, I guess, I might start going faster now. What I think good architecture is, and should be a good architecture should produce, is understanding the trade-offs. It's kind of the whole point of my story, is really understanding the trade-offs and that everything has a trade-off. And that's the key. That's the key to good architecture, which is not just the responsibility of architects but of software engineers, is to understanding why you're making the decisions, which is quite tricky. I understand it requires a lot of time of reading and thinking, probably, and discussion. and anticipating change in the general sense. So I find planning for change by writing readable code, and by writing code, say, that has its dependencies injected into it, things like that, rather than writing code that, okay, we want to have a configurability point on how many files we stream at the same time. If there's no requirement for that, you're just adding in more complexity to code. If you make the code less complex, then just by doing that, you're making it more able to change in the future because it can be read more easily. That's what I think by anticipating change in the general sense is. And deferring decisions, I think this is one thing that developers as well, everyone kind of loses track of. Actually, the system that we're currently working on right now, it's greenfield, and we started in November or early December, and we don't have a database yet. Technically we do, we store files on disk. We thought that it would be best while we're developing our data model it would be simpler to save a file on disk, especially as we were working with reading in and out XML files and reading from that XML file. And some people on our team wanted to break up that file and store it in a database. Like, say there's hundreds of different components to the XML file, and each one would have been a table. And we kind of said, we'll postpone that, we'll defer that until we need to. And we're 6 months down the line, and we're actually going completely fine. We're not having any real scaling problems, maybe some performance problems, but us putting off our decision to have a database, as we probably will still put one in, but it's been kind of eye-opening, the fact that it hasn't created problems. People thought we'd have a whole load of problems, but instead we've been able to develop faster because we haven't had to manage schema changes and version changes to the database and keeping it up to date. Bad architecture is choosing silver bullets. So I think that's the whole trade-off thing. If someone has a silver bullet, whether it's a language or a tool or a way of working, I'm really, really skeptical of them. Even the things that I talk about really liking, like pair programming and test-driven development, I think I could argue against them and argue for the other side and know where the balance is. I think that's the reason why I like them, is because I've worked with them enough that I've seen how too much pairing and too much TDD can go down the wrong path. So I've kind of been burnt enough that I know what the middle ground is. Anticipating specific changes, what I said before, if you're trying to plan for specific changes, what ends up happening, I think, is the changes that you anticipate don't happen and ones you didn't anticipate do. And your extension points end up being all wrong and difficult to modify. And I think the worst thing, and this is kind of the antithesis of agile and what waterfall was supposed to be all about, and agile, I guess, is supposed to not be about, is taking upfront decisions, especially ones that are locked in. To me, I think it's all about, so this is the opposite of deferring decisions. It's all about giving yourself enough options so that if you've made the wrong decision, you can undo it. It's kind of welcoming failure. So saying I'm going to make an upfront decision and we're locking in forever says that whatever we make now, it can't fail. So you'll spend a lot more time thinking and worrying about it. And probably, because you're so locked into it, a lot more time, if it does fail, a lot more time trying to make it work. Whereas if you give yourself options, if you use the right abstractions and don't lock yourself into, say, too many frameworks, then if something goes wrong, say support for a framework drops or completely changes, you can actually respond to that change. So I think, after this little rant about complicated architecture and architects, I think the main problem is that, like what I kind of said before, is that architects are the same as developers. So normally an architect is a developer that's kind of moved up the ranks and got more responsibility. And if a lot of developers, if we're tended to write more complicated code, we're probably tended to write more complicated systems. So that's a really big problem, and I have a big silver bullet solution for that. No, I don't actually. I think that's a really, really hard one, I think. I can't pretend to have a solution. It's like a psychological thing and a cultural thing, and it's normally an organisational thing. If you have a team of architects that push technologies and solutions down onto other developers and force them to take power away from them and force them to work a certain way, and that makes everyone ineffective, they actually probably got there because that's the kind of culture and the work that the business wants. So I don't know. I can't solve that problem. I'll come back next year maybe. Alright, so I've been going for almost an hour. Maybe I'll just skim past the UX part. This is like the fun part. I'm not like a UX guru or anything. I just see a lot of really bad UX. So I really like this slide. This is years old, but I don't know if anyone's seen it. But it speaks so much truth to me. Apple and Google have these products that just have a couple buttons and things on them, and then I seem to work on websites and web applications are just like this. I just Googled, I went Google image search for enterprise UI design, and this came up. And I just think that's perfect. I've worked on systems like this before, and I've been that guy. I went into a brownfield system.
Fizzbuzz UI?
This is I worked on a system that looks like this. This is, you can see this is actually SAP, right? It's like a German SAP screen. So someone's built this. Someone's probably dragged and dropped all this in here, and it's hooked up to a database and thought, this is brilliant. Everyone just put all their data in here. Everything's probably required as well.
Do you think can it be simplified?
Sorry?
Can it be simplified? You think?
Everything can always be simplified, but it's maybe it's hard. So I'm just putting up this here as a bit of a joke, but the first thing would be maybe, do we need to actually capture all of this data, right? That'd be the first question.
Do you
what
have
data
to
do we
always show the same set of data to the user?
Yeah.
Because as the number of fields in a screen increase, actually, the distribution of the usage of the fields converge to normal distribution, which means actually there are only a few fields that you most see and edit, and there are extreme fields that you very rarely see and edit. So you can apply the normal distribution in terms of the visibility of the fields.
Just as an addition to this, I worked in insurance product some time ago. We had screens like that as well, but that was the thing the operators wanted. The operators at that time, they loved to work with screens like that.
Exactly. Maybe they didn't know how good how much better it can be.
So we can give you some nice good pop-ups you can type. But mouse button, they say no, we don't need to think of it. Trading solutions, derivative products. That's the same. In more specialized UIs, you will not need a simpler UI. That's the same. So all the usability thing comes in, if you want to become more mainstream for more users. But if only 5 people are using the system, you don't need to actually go into the simple UI.
True.
They might need to go exactly that. Yeah, exactly.
Consider this as well. A more complex screen pretends that the person using it is actually a more expert and working on it.
It's domain driven. If the domain requires all that complexity, you have to give it.
I think that we end up arguing about this stuff, and we can. It's just all subjective. And so, has anyone heard of lean startup or lean software development? So it's supposed to be metric focused, right? And lean UX is something I really like, but I've never been able to really push that at a company. And I think enterprise is probably just not interested. But we could actually put arguments to rest by actually capturing data on how users use systems, and then do. And your example about 5 users is probably worthless to putting the effort into that. But if you had more users, you could capture metrics on how they're actually using it, and then show them different screens to find out whether or not having less fields on the same screen actually results in higher use, things like that. So we can actually, rather than just put all our opinions, what this ends up happening is it's just everyone's opinion about how it works, or a user just tells you how they want it to work, and they don't even realize how much better it could be. I mean, we just have a quick example where we're building a system where the users are very technical. We only got about 10 users. They're optimizing nuclear power stations in France, right? So they have lots of data that they use, and they're asking us to show them just as much data as possible, always, because their existing tools are Excel-based and have lots of data. But when we kind of tease questions to them, we ask them, say they wanted to see when something started and ended, or they wanted to see it goes through like a pipeline, they wanted to see what time it went through each pipeline, and you actually ask them about why they want that information, so they can find out how long it took. But we could just show that to them. We could say it took 3 minutes, it took 5 minutes. Then we asked them deeper, why do you want to find out how long it took? And they said, we want to know how long it's got to go. Well, we said, well, we can make a progress bar that goes off the average last few times it's run, that counts down. And so it's by teasing out these, like, why do you actually want to see it, you can simplify the UX.
Can we make a comment like this as well? When users actually are expected to describe their needs, actually, they have a background of their previous user experiences from older technologies, and actually all the technologies make up their imaginations, which form their way of statement of their expectations. While actually good developers may have better understanding of how a function, how the intent could be better implemented, so we can guide the users for better description of their actual needs.
I think a lot of the problem can be, though, that as developers, a lot of us aren't very good at this. So developers write a lot of enterprise screens and they get used to working that way and they want to just keep working that way. Whereas maybe if there was more of a UX focus in enterprise development, it wouldn't be like this. That's what I think.
Better user experience in that page is better tab order and shortcuts to direct to the
That's a
fields.
start.
And the user asks for that.
That's a start. Then you can do measurements. I don't know. I don't know what the screen is, but maybe you could measure what fields are being used most often. There might be a lot of optional fields, right? That maybe you could hide the majority of that unless they need to find that. There might be only 10% of the fields that they use, so you could display them first, right? You could try to autofill. I don't know. There's lots of things you could do. I like this. I thought this would be the fastest. I'll get through these the fastest, but everyone has an opinion on user interface, right? Everyone has an opinion.
There are a bunch of developers trying to solve your problem.
Yeah. I think that developers overall aren't very good at user experience. I think that for these reasons, we're normally really focused on solving the actual business problem. And so while you're focused on the little feature that you're building and you're writing it yourself, you know exactly how to use it and how it works, right? And maybe you can explain that to someone else, but you never really come at it from a first-time user, right? Which maybe in a lot of in some applications it doesn't matter because you're going to get training on it, or as I say, or enterprise applications. It's not like you can put an app in front of them and they say, no, I'm not going to use that. I'm going to use Barry's app that he built down the hall because they don't have competition. It's not like in the open market, right, where you have different apps are competing on different levels of user experience. So for those reasons, I think UX suffers, and people either maybe don't feel like it's worth putting the attention to detail, or they by accident they don't end up really improving the UX because it's not seen by anyone as important.
Enterprise applications have computers, but all of the screens were nearly the same.
All of the
Screens, SAP screens and other computers, Microsoft X or other computers, screens are nearly the same. I was working for one of the companies in Turkey for many years, enterprise solutions, and users ask that not for basic or clear screens, they ask for more columns and more fields.
Yeah, they want more features, right?
Right.
I think it's tough maybe, especially if your users want that. I mean, you've got to give them what they want, but maybe what I'm saying is I don't think that's what they really want. They don't know that it could be better.
Maybe as you didn't like microservices, maybe they don't like micro pages.
Micro pages, you know? But one thing about this, about talking about complicated user experiences, that I think it's in our interest to focus on making things more simpler, is that, so not only, okay, this is controversial, I suppose, from people going back and forth, that simpler means generally better. I think the more options that you have on the page means it's a less overload on the user and they can make a decision more effectively. So maybe giving lots of information, and especially visualizing information well, is important. But then the actual options you have to take, was there many buttons on that screen? Yeah, there was lots of different buttons. So minimizing the amount of actual decisions. I wish
the scroll button. When you scroll down the page, you see the scroll button. Scroll down
The buttons are hidden, yeah.
Yeah, the buttons are downwards.
So the less decisions a user has to make, the better, the more focus they can have, and they can make the right decision, right? And they won't make a mistake. But what I think is most important, why it's better for a developer to make things simpler, is it's less implementation work. So the less features, the less things that you have to put onto the screen, the less work we have to do, and the less work it is to maintain it. So if we push for building simpler user interfaces, that's less UI code. That means there's less JavaScript for us to write and have to look at, right? Which is a good thing.
May I make a comment in terms of these micro pages? When you were when a friend actually gave an example of users accepting more and more columns on a page, I was in that situation as a user a few days ago using my own CRM software, Salesforce software. The reason I was asking more and more columns on the page was because adding more columns on the page wasn't an easy job. So whenever I need a new column, or whenever I need an invisible column to be visible, it was taking in order of tens of seconds to show the column. That was a problem actually. Probably showing a small number of columns, but making it much faster to be able to show a column, maybe better solution. In that case, users will not ask more and more columns on, knowing that actually it is very easy, just one click to show a column. Or two clicks.
I think
Because even those users who want 20 columns on the pages, they know that actually most of the time they are using 5 columns or so. But they think, just in case I may need this, just in case, show them that actually it is this fast to show whatever column you like.
Yeah.
If it is not as fast as required, then they ask more and more columns on the screen.
This is all contextual, right, though?
Yeah,
It depends really on the context. Like, I prefer, rather than having lots of options on the page, I like being able to search, maybe, for things. So especially if you've got, like, everyone has grid views, right? All enterprise software has lots of big grid views. And I feel that that's giving up. That's when you're making the user search through the grid view themselves. But I think every enterprise place I've worked at, the users have been asking for grid views. And I don't just end up fighting with developers, because I really believe that grid views are a really inefficient way of building UIs. I don't fight with developers, I end up fighting with the users, and I pretty much always lose that.
It depends on the project actually. If you are developing a software for websites, for the public, for example, Facebook configuration page.
Yeah.
Okay, so billions of users they are going to use that.
Of course, so it's a lot more.
Simplicity is the first there actually, because you can't teach it. How to use form to video.
And if you save 1 second of time for a billion people, that's a lot of time saved. Right?
But if you are developing something for a team, for example, customer service team, they may want to see as much as they may want to see lots of data in a single page, in a single screen. So they will prefer the more complex screen. So the definition of the good UI depends on the.
So I'd still selfishly fight back against it because I want to have less code to maintain, right? So I push back wherever I can. So I think a lot of places, a lot of the time though, it's up to developers to focus on UX, and then that's when we can either say, well, actually, I have much more important things to do with my time, or that actually UX isn't that important. So I think that if you're working with really complicated designs, maybe it's up to the developers to step up a little bit and ask the question, could it be simpler? So what you can do is think about the UX before even accepting a feature, whether or not we need that feature. Think about it when building, and something which I think sometimes is forgotten is that an API is a user interface. So UX actually comes down to external APIs that you may be releasing over the web, or if you're building a library that's going to be reused, how you build your API is quite important. But it even comes back down to the internal bits of the code, right? Everything's a user interface. It's just different types of users. Some user might be the developer who's sitting next to you. Okay, I have a summary slide. I think this whole talk has mostly been about developer empowerment. So asking developers to challenge the business over complicated features, challenge your peers over complicated code and architecture, and challenge yourself to make things simpler. That's it.
Thank you.
Questions?
It's hard to ask questions for this kind of topic. Actually, it's not. It's not
Just starts the discussion, right?
Yeah.
Yeah, I've got a question actually. You work as a contractor, and you know, like when you work for a company, there is some perm guys and some architects or solution architects. They might be responsible for the existing projects. And when you discuss about this, you know, simplicity things, they might challenge you. And because you are a contractor, at some point maybe you're gonna say that, you know, okay, I don't care because, you know, they want to implement in this way. Have you had this type of experiences, and how did you act?
Actually, on the thing that we're working on right now, we went through a phase of the first few months where it was a team from a consultancy that came in, and to a company that isn't really used to working with consultants, and with a couple of people in particular on the team that were, I guess, really worried about, like what you're saying, that we're going to come in and we're going to write code that's in a different coding style, using different tools and different frameworks, and it's going to be unsupportable. Actually, the word support was used a lot in the first few months of us working on the project. The idea that we have to make sure that we work in the same way as the company we're working for, otherwise they wouldn't be able to support it after we left. Sometimes it was used it seemed just as a throwaway excuse, actually, just like I don't like what you're doing, it's not supportable, instead of having an actual discussion. And we ended up compromising a lot. So like individuals personally compromising on what we considered to be a good approach or a good library or a good framework because it was the standard way of working at that company, but not compromising on parts that we thought were more important. And so the whole idea of deferring decisions, because that's going to let us kind of deliver faster in the short term while making sure that we choose the right decision at the right time. And what happened really though is over a few months we built up trust. None of us had worked there, contracted there before. We built up trust with the organization that we're not that we don't want to just push our own way of working, that we actually thought about the ways that we work. We've actually put thought into the trade-offs on them. And sometimes, I mean, you lose battles and you win battles. Some of the battles that we've won have actually, it seems the greater organization has taken note, which is what the idea of getting externals in is supposed to be, right? Is that you see different ways of working and maybe you learn. And sometimes we've had to accept that, okay, no, we had a really long back and forth about writing comments. I believe that writing comments in code, being forced to write comments in code, wasn't really helping the maintainability. It was costing us time, and it was also encouraging you to not write as clean code as you could have, because you can say I had a comment. But we kind of lost that fight, and they said no, we require comments, and we had to start putting comments at the top of our classes. We kind of compromised on that. But I mean, it's hard because if I'm supposed to be here temporarily to deliver a system, how can I argue with them when they say that our guys won't be able to support it? I can't really. All I can do is just kind of show that if I think something is good, clean code and is supportable, I have to kind of write the code like that and then show it to them and build up trust.
Why do you think